Hey everyone, and welcome to Science Wonders. Today, we're blasting off on a cosmic adventure to explore the universe's greatest mysteries. Get ready for 10 mind-blowing facts about physics that will make you question everything you thought you knew about space. The fact that the universe is expanding is a mind-blowing concept that challenges our everyday intuition. Let's make a closer look. In 1929, Edwin Hubble, an American astronomer, made a groundbreaking observation. He studied the light emitted from distant galaxies and noticed a surprising pattern. The light from these galaxies was shifted towards the red end of the spectrum, a phenomenon known as redshift. This redshift is typically interpreted as a sign that the galaxies are moving away from us. The farther away the galaxy, the greater the redshift observed. Imagine an ambulance with a siren approaching you. As it gets closer, the sound of the siren gets higher pitched. Congratulations! Now you're discovering the Doppler effect. Conversely, as the ambulance moves away, the sound gets lower pitched because the sound waves are stretched out. In a similar way, the redshift observed in light from distant galaxies suggests they are moving away from us, causing the light waves to stretch out and shift towards the red end of the spectrum. Hubble's observation, along with other evidence, led to the theory of the expanding universe. Think of the universe like a giant fabric dotted with galaxies. The galaxies themselves aren't necessarily hurtling through space, but rather the space itself is stretching in all directions. This expansion causes galaxies to appear further apart over time. The theory of the expanding universe is still being explored and refined by scientists. The concept of dark energy is thought to be a driving force behind this expansion. Forget the idea of a giant cosmic castle. Unlike our solar system with the sun at its center, the universe has no central point. Everywhere you look, you're gazing outwards from your own little corner of the cosmos. The idea that the universe has no center can be a bit mind-bending, so let's discover it. We often imagine the Big Bang as a giant explosion that hurled matter outwards from a central point. However, that's not quite accurate. Instead, the Big Bang is thought to be the rapid expansion of space itself. The entire universe, including space itself, was incredibly dense and hot in its very early stages. Because space itself is expanding, any 2 points in the universe are constantly moving further apart. It's not like we're at the center and everything else is moving away from us. No matter where you are in the universe, you're essentially at the center of your own observable universe, with everything else seemingly moving away. This concept has some interesting consequences. There's no edge to the universe, either. The universe appears to be infinite, or at least very vast, and the expansion applies throughout the observable universe. However, the question of what lies beyond the observable universe remains a mystery. The universe is vast, but what we can actually observe is a fraction of the whole picture. This observable universe is limited by the speed of light. We can only see things that have had time for their light to reach us since the Big Bang. What lies beyond that? Light, the fastest information carrier we know of, travels at a constant speed around 299,792 kilometers per second. The Big Bang, the prevailing theory for the origin of our universe, is estimated to have occurred roughly 13.8 billion years ago. Since light has a finite speed, it takes time for it to reach us from distant objects. The observable universe, therefore, is limited to the region from which light has had enough time to travel and reach us since the Big Bang. Imagine a giant bubble expanding outwards. This bubble represents the observable universe. The edge of the bubble isn't a physical barrier, but rather the limit of what we can see with our current technology. Light from beyond this limit simply hasn't had enough time to reach us. Based on the estimated age of the universe and the speed of light, scientists estimate the observable universe to be roughly 93 billion light-years across in diameter. The fact that the observable universe is finite doesn't necessarily mean the entire universe itself is finite. We simply can't see beyond this limit with our current technology. The universe could be much larger, potentially even infinite. However, anything beyond the observable universe remains a mystery for now. The observable universe is constantly growing as time goes on. More and more of the universe becomes observable as light continues to travel towards us. The concept of the observable universe is distinct from the entire universe itself. We can only study and understand the part we can actually observe. The finite nature of the observable universe is a fascinating consequence of the laws of physics and the vastness of space and time. It continues to drive scientific exploration and our quest to understand the universe we inhabit. Look around you. Seems pretty solid, right? Well, physics throws a wrench in that. Dark matter, an invisible substance, makes up about 85% of the matter in the universe. We can't see it directly, but its gravitational effects on visible matter tell us it's there. The key challenge with dark matter is that it's invisible. It doesn't interact with light or other forms of electromagnetic radiation we use to observe the universe. Therefore, we can't directly see dark matter or take pictures of it. So, how do we know dark matter exists? The answer lies in gravity. We can observe the gravitational effects of dark matter on visible matter. For example, galaxies spin too fast to be held together by the gravity of the stars and gas we can see. This suggests the presence of invisible matter, like dark matter, providing the extra gravitational pull needed for stability. Scientists are actively researching dark matter, trying to understand its properties and composition. There are various theories about what dark matter might be, ranging from weakly interacting massive particles to sterile neutrinos. Large experiments are underway to try to detect dark matter particles directly. Understanding dark matter is crucial for our complete picture of the universe. It plays a significant role in galaxy formation and the large-scale structure of the cosmos. If we can unlock the secrets of dark matter, it would be a major breakthrough in our understanding of the universe's evolution and composition. The universe's expansion isn't slowing down, it's actually accelerating. Dark energy, another mysterious force, is thought to be the culprit. We don't fully understand dark energy either, but its influence is causing the universe's expansion to speed up over time. We know the universe is constantly expanding, with galaxies moving further apart over time. This expansion was originally thought to be slowing down due. However, recent observations suggest something surprising. The expansion of the universe isn't slowing down, it's actually accelerating. This unexpected discovery points to the existence of dark energy. Dark energy is a mysterious force or property of space itself that is thought to be causing this acceleration. It makes up about 70% of the universe's energy content, even though we can't directly detect it. Unlike gravity, which pulls things together, dark energy seems to have a repulsive effect, pushing the fabric of space-time and causing the universe's expansion to accelerate. It's like an invisible force pushing galaxies further apart at an ever-increasing rate. The exact nature of dark energy remains unknown. There are various theories, such as a cosmological constant or quintessence. The long-term effects of dark energy are a topic of ongoing research. Some theories suggest that dark energy will continue to dominate and cause the universe to expand exponentially, leading to a cold and lonely future where galaxies become increasingly isolated. Dark energy is a fascinating puzzle with significant implications for the fate of the universe. As we continue to explore the cosmos, hopefully, we'll unravel the secrets of this mysterious force. Our sun might seem like just one star among many, but it's the heavyweight champion of our solar system. It accounts for a whopping 99.86% of the solar system's mass. The planets, moons, asteroids, and everything else are just cosmic crumbs compared to our giant star. Okay, how we discovered earlier, the sun holds a whopping 99.86% of the total mass within our solar system. That means everything else, from planets and moons to asteroids and comets, combined makes up a measly 0.14%. This immense mass of the sun is the reason it exerts such a powerful gravitational pull. This gravity acts like an invisible leash, keeping all the objects in our solar system in their respective orbits. Think of the planets, moons, and other objects as celestial dancers. The sun's gravity acts like the music, dictating the pace and path of their dance. Their orbital speeds and distances from the sun are determined by this gravitational influence. The sun's mass also plays a crucial role in other solar system phenomena. It's the source of light and heat, vital for life on Earth and powering various processes throughout the solar system. The sun's immense gravity also helps shape the solar wind, a stream of charged particles that flows outwards and interacts with planets and other objects. The sun's dominance in mass helps maintain a relatively stable solar system. The vast majority of the mass being concentrated in the sun creates a predictable gravitational environment where planets and other objects can orbit in a balanced way. Billions of years from now, as the sun nears the end of its main sequence life and transitions into a red giant, its mass will play a significant role in its evolution and how it interacts with the inner solar system. Even though the sun is the solar system's mass champion, it's not the biggest star in the universe. There are stars out there hundreds or even thousands of times more massive. This fact highlights the importance of the sun's mass in shaping our solar system and underlines its role as the central force governing the celestial dance of its components. Imagine a celestial object so dense that a teaspoon of its material would weigh 1 billion tons. That's a neutron star. The immense gravity within a neutron star packs neutrons together so tightly, creating a mind-bogglingly dense object. A single teaspoon would be heavier than all the buildings on Earth combined. Neutron stars are born from the dramatic collapse of massive stars after they run out of fuel and can no longer support themselves through nuclear fusion. During this collapse, the immense gravity of the star overcomes the outward pressure from nuclear fusion, squeezing the star's core into an incredibly small volume. Under this extreme pressure, the protons and electrons in the star's core get squeezed together. Protons and electrons combine to form neutrons, which are much denser particles. In a neutron star, the immense gravity packs neutrons together so tightly that there are practically no gaps or empty spaces between them. This creates a state of matter unlike anything found on Earth. The result of this incredible compression is a mind-boggling density, a teaspoon of material from a neutron star. That tiny amount would weigh billions of tons. It's like cramming the mass of a mountain into a thimble. To truly understand a neutron star's density, it's important to remember that density is mass divided by volume. Neutron stars have a relatively small volume but an incredibly high mass, resulting in this extraordinary density. The high density of neutron stars has strange consequences. Their gravity is so strong that even light has difficulty escaping their surface. The extreme pressure also creates exotic forms of matter not found anywhere else in the universe. Neutron stars are a testament to the power of gravity and the strange wonders that exist in our universe. Their mind-blowing density continues to fascinate scientists and inspire our understanding of matter under extreme conditions. Black holes are cosmic vacuum cleaners with a one-way policy. Their gravity is so strong that not even light can escape their grasp. Anything that gets too close gets swallowed whole, disappearing from the observable universe. Black holes are truly mysterious and powerful entities. Black holes are born from the collapse of massive stars when gravity overcomes the outward pressure from nuclear fusion. The collapse continues until a point of singularity is reached, a place where all the mass is concentrated in an infinitely small point, although scientists believe this is a theoretical singularity and not a physical reality. Surrounding the singularity is a region called the event horizon. This is a point of no return. The escape velocity, the minimum speed needed to escape the gravitational pull of the object, at the event horizon of a black hole exceeds the speed of light. Even light, the fastest thing in the universe, cannot escape the pull of a black hole once it crosses the event horizon. Imagine a cosmic cliff. Anything that falls past the event horizon is gone from the observable universe forever. What happens beyond the event horizon remains a mystery. Our current understanding of physics breaks down at that point. Scientists are actively theorizing about what lies within a black hole, but it's beyond direct observation. While we can't directly see a black hole, we can observe their effects on surrounding matter. The way stars and gas behave around a suspected black hole can provide evidence of its presence. Black holes are fascinating and complex objects that continue to challenge our understanding of gravity and the universe. The concept of not even light escaping their grasp is a testament to their immense power. Scuti holds the title of the largest known star by radius. It's an absolute monster, estimated to be over 1,700 times larger than our Sun. That's a staggering difference. If it were placed at the center of our solar system in place of the Sun, its immense size would engulf everything within the orbit of Neptune and possibly even farther. Mercury, Venus, Earth, Mars, the asteroid belt, and even the gas giants Jupiter and Saturn would all be swallowed whole. Imagine the Sun as a giant beach ball. Scuti, in comparison, would be a colossal hot air balloon dwarfing the entire Earth. The vast difference in scale is difficult to comprehend. Scuti is a red supergiant, a type of star nearing the end of its life. These stars are massive but not incredibly dense. Our Sun, a yellow dwarf, is much smaller but packs a higher density. Despite their immense size, red supergiants like Scuti have relatively short lifespans compared to stars like our Sun. They burn through their fuel quickly and eventually explode in a spectacular supernova. Scuti serves as a reminder of the incredible diversity and scale of stars in the universe. It highlights the vastness of space and pushes the boundaries of our imagination. This fact truly highlights the mind-boggling scale of the universe. Here's a breakdown to help you understand. Scientists estimate that there are more stars in the universe than grains of sand on all the beaches on Earth. That's an almost incomprehensible number. There are countless beaches on Earth, with trillions of grains of sand on each. However, the number of stars in the universe dwarfs this by a vast margin. Estimates suggest hundreds of billions of galaxies, each containing hundreds of billions of stars. The sheer size of the universe itself contributes to this staggering number of stars. Galaxies are vast collections of stars, gas, and dust, and they are spread out across the observable universe in immense numbers. This vast number of stars tells us a few things. First, it suggests that planets, potential homes for life, could be quite common throughout the universe. Second, it highlights the possibility that we might not be alone. With so many stars, there's a good chance that life exists elsewhere in the universe. The vast number of stars is a humbling reminder of our place in the cosmos. It ignites our curiosity and inspires us to explore the universe and search for answers to the question, are we alone? That was a mind-blowing ride through some of the craziest facts about physics, wasn't it? The universe is truly an amazing place, full of mysteries waiting to be unraveled. If you enjoyed exploring these cosmic concepts with me, hit that subscribe button and join the channel for more adventures in science. Thanks for watching, and see you next time on Science Wonders.